Hi everyone, this is Janine aka Janine the Tutor. As you know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure. And as a part of OneClass, we are very fortunate that we are able to adapt quickly. That's why we are running free and daily classes for math and chemistry from grades 11 to first year college and university. In addition, we are also giving away 100,000 hours of free private tutoring for students to stay on top of your studies, and this is for students across North America. So, for today's class, I will be going over and covering geometry. I believe we haven't really finished what we've been learning from last class, so we're just going to continue on. And for the rest of the class, we will be going over parallelograms and the other quadrilaterals, which are rectangles and rhombuses. Great. Before I get started, I just wanted to make sure that you can see my screen and you can also hear me coming through. Okay, great. Yeah, so just going back to whatever we're talking about from last class, right? So we were talking about special angles, and typically when you have this two parallel lines over here, sorry, two lines forming a parallel line, right? And then you have a transversal, right? So a transversal basically cuts a pair of parallel lines and then they create two distinct points, right? And depending on where you are, right, on your transversal, that would be either supplementary, right? Meaning the two angles would sum up to 180 degrees, or they're going to be equal to one another, which means they're congruent. Okay, so if you try to rotate this, right? So if you think about having the parallel lines like this, and then you have this transversal over here, right? So if you think about rotating this clockwise 90 degrees, right? So this way, you know that this x minus 15 degrees is over here, and this x plus 25 degrees is over here, right? Because they're on the same side of the transversal, right? So x minus 15 degrees is here, and you have this x plus 25 degrees on the same side of the transversal, meaning they're corresponding angles, right? Same side of the transversal, meaning they're corresponding. So in that case, they're also exterior angles, right? Remember what I said about if you have two lines, right, and they're parallel, anything that's outside, basically they're exterior, right? So they're exterior and they're corresponding angles. So because they're on the same side of the transversal, right? So if you think about having this and this, right, x plus 25, so what can you say about the two angles, right? So if you're not really sure, because we didn't really mention anything that correlated for corresponding, right? So remember we talked about corresponding angles and exterior, but we did not have corresponding exterior angles, right? We only had consecutive exterior angles, and that's pretty much it. However, because we're saying that they're corresponding angles, right, regardless of whether they're interior or exterior, that means if they're corresponding, they're in the same position, therefore they're going to be congruent, meaning they're going to be exactly the same angle. So we can have x minus 15 degrees, and that's equal to x plus 25, and then you're solving for x, right? So let's see. Actually, if you had okay, maybe we can just go this route. So because I mentioned they're corresponding, right? But what if you turn them into alternate exterior angles, right? So let's say if you have this over here and this over here, right? So this angle, right? If you were to look for this, right, for you to kind of infer that they're alternate interior angles, right? Because we know what the correlation is between two angles that are alternate and they're exterior angles, right? So let's say if you have x minus 15 degrees, you would have this being 180, right? So let's say you're looking for this. So you would have 180 minus, actually, if you have this, yeah, you can't really say anything about this because you don't know what the variable here is, right? Let's say, yeah, okay, so if you think about this, right? we can actually just use this. Okay, sorry about that. So let's just look at this figure over here, right? So we had x minus 15 and then we had x plus 25. So if you think about x plus 25, right? If you had x plus 25 over here, right? We can actually just get rid of this. Okay, if we had x plus 25 over here, right? That means they're corresponding angles, right? So they're on the same side of the transversal, right? And also, it's this F pattern. I'm not sure if I've talked about that from last class, but basically, if you have an F pattern, that means this side and this side, right? They're actually the same, right? So you can actually say that x plus 25 here is the same as x plus 25 here. So if you know that this is x plus 25, right? Therefore, because you have a straight angle, that means you have x minus 15 plus x plus 25. This would give you 180 degrees. Yeah, and that's it. Okay. So you don't really need to rotate this. I just realized that you can just look at the figure, right, and have x plus 25 here and this equal to one another, and then you can just have 180. So this is 2x, and you have 25 minus 15, so that would be 10, right? And this is going to be 180 degrees, right? So once you have that, 180 minus 10, right? So you have 2x is equal to 170 divided by 2. Okay, so 170 divided by 2 is equal to 85, right? So you know that x is equal to 85. Therefore, if you would have to solve for this and this, well, this, right? That means 85 plus 25 would give you 110. So this angle is 110 degrees. And this, on the other hand, you would have 85 minus 15, and that's equal to 70 degrees. Okay, there we go. Okay, so yeah, we can actually use the F pattern. I think this is the most straightforward concept to apply. And yeah, we have 70 degrees and 110 degrees. Okay, great. So let's proceed to the next figure. Okay, so here we actually have alternate exterior angles, right? So if they're alternate exterior angles, that means they're going to be congruent. So you have 7x minus 1, right? And this is equal to 6 plus 8, right? Solving for x, you have x, which is equal to 8 plus 1, and that's 9, right? Let's see, 7x minus 1 equal to 6x plus 8, and that's equal to 9. And first of all, if you're wondering where how did I know that they're alternate exterior angles, if you go back to this, right? If you look at the x over here and the x over here, or this squiggly line over here and this squiggly line over here, it's very similar to, and what did we say? They were actually congruent, right? So we can actually apply that concept here, right? Remember the x that I showed you? Yeah, so they're equal to one another. That's why I equated the two equations equal to one another. So you have x is equal to 9, and all you have to do is plug in x, right? To get this angle and this angle, right? So you have 6 times 9, right? And then you have plus 8, so that equals to 62 degrees. And then on the other hand, because you know that they're exactly the same, right? So 7 times 9 minus 1 is still 62. Okay, great. So, okay, let's proceed to the next one. Okay, so as you can see, we have two angles, right? And they're not in the same position within your transversal, right? Because you have one angle that's on the left of your transversal, and on the other hand, you have one angle that's on the right of your transversal. So that means if you look at let's say this one is exterior, right? Which it is, and you have an interior angle over here. So that means you can't really say anything about alternate interior angles or exterior angles or consecutive, right? Interior or exterior angles. So what you can do, right? You know that this is 3x minus 15, right? So let's say you're going to find an angle that's exactly 2x degrees, right? So if you remember our x, well, it's not an x pattern, but it's a z pattern over here. Can you guys see this? Okay, we can use this. Great. Yeah, but basically it's a z pattern, right? It's from here, then you have here and here, right? So remember for Z pattern, right? So whatever this is, right, it's going to be exactly 2x degrees, right? So anytime you form a Z pattern, they're congruent, right? So if they're congruent, if you have 2x degrees, right, and you have 3x minus 15, and you're seeing that you have this transversal, which is equivalent to a straight angle, which is 180 degrees, that means you can say that this is 3x minus 15 plus 2x, and that's equal to 180 degrees, right? And you can just solve for x, right? So you have 3x plus 2x, that's 5x, and that's equal to 180 plus 15 divided by 5, right? Because you want to isolate just x. Okay, 180 plus 15 is equal to 195 divided by 5. That should be equal to 39. Yeah, it's 39. So x is equal to 39 degrees. Okay, so once you know that this is 39 degrees, right, then all you have to do is plug in your x. So 2 times 39, that's equal to 78 degrees. And then you know that this is 3x minus 15, so technically it is 180 minus 39, right? So maybe you can do that. 180 minus 39 is actually 141 degrees, right? So even if you try to do 180 minus 78 degrees and you would get this angle, so on the other hand, you can actually take 39 times 3 minus 15, and that's equal to, let's see, 180. Oh, actually, this is 39. So we said this was 78. So 180 minus 78, that's what I meant, not 39. Because the angle here is 78, right? So 180 minus 78, that's equal to 102, right? Okay, so if you were to use 39 as your x, right? If you plug 3 times 39 minus 15, you should get 102. Yeah, so just be careful. Just because you have x is equal to 39, that does not mean that the angle is 39 degrees, right? Because this one is 2x. Therefore, you're taking 180 minus 78 to give you 102. Or alternatively, you can actually take 39 times 3 minus 15, and you still get 102 degrees. Great. So moving on to the next one, right? So now we can actually see that they're interior angles, right? So you have 147, and this is 2x minus 23 degrees, right? So if you go back to the terminologies that we've learned so far, so we do have consecutive interior angles and exterior angles, right? But for them to be consecutive, that means they have to be side by side, right? So if it's interior, therefore it's going to be this. If it's exterior, it's going to be outside. So it's right next to each other. But if we're looking at this, right, they're not really exactly right next to each other. So it's not like 147 and you have 2x minus 23 over here, right? So they're only corresponding angles, right? So when they're corresponding, that means if you have this being 147, right, that means you can actually say that this 2x minus 23, right, is the same as this one. Okay, so you have this and you have this. Can you guys see this? Okay, so whatever this angle is, right, that's exactly the same as 2x minus 23, right? So if you're saying that this 2x minus 23 is the same as this one, right, therefore you know that if this is 2x minus 23, right, that means 2x minus 23 plus 147 should give you 180 degrees, right? Okay, so once you have that, you're going to solve for x. So 180 plus 23 is equal to 203, right? So 2x is equal to 203. Does that make sense? So if I were to erase this again, right, and let's see. Okay, so if you have 147 rather, and let's say you're using this. Okay, so remember the F pattern that I showed you? Okay, so you have this and this, right? So if this is 147, that means this has to be 147 as well, right? And if you go back to the F pattern that we talked about, right? Whatever is on the same side of your F, right? So, okay, so if you remember, an F looks something like this, right? So whatever this angle is, right, that's going to be congruent to this angle. Does that make sense? That's why when you have this F over here, this is the same as this one, right? And it's similar to this, right? If you have 147, this needs to be the same angle as well, right? So that means this has to be 2x minus 23. And that's why when you have 2x minus 23, you need to add this to 147 to give you 180. And the reason why you can't really subtract from here, it's because you don't really know what the variable is, right? So even if you were to do 180 minus 2x minus 23, you can't really solve for x, right? So that's why it's either you have this or you can just do 180 minus 147, right? Okay, I'll show you two options in order to solve for this. Okay, so let's go the first route. So basically it's 2x minus 23 plus 147, that's equal to 180, right? And then you have 180 minus 147, that's equal to 33. And you still have the minus 23 over here, so you're going to add 33 plus 23. So that would give you 56. So 2x is equal to 56. Dividing both sides with 2, so you have x is equal to 28, right? So this is the first route. The second one, or the second option you can actually solve for x, is because you know that this is a whole number, which is 147, and you don't have any variable to begin with. That's why you can just take 180 minus 147, right? So if you have 180 minus 147, that means that's equal to 33, right? And once you know that this is equal to 33, so there's only two angles, right? If you're forming a straight angle, therefore you have 2x minus 23, right, which is equal to 33. So yeah, it's very similar. So you have this over here, and then all you have to do is add 33 plus 23. So 2x is equal to 56 divided by 2. So you should end up with x is equal to 28. Yeah, so it's the same thing, right? Two options. Okay, so once we have 28, all we have to do is plug in 2 times 28. And this is minus 23, so this has to be 33 degrees. By the way, all of the session, all of my sessions will be recorded, so you don't have to write this down. And you can also go back to the things that you've missed so far at your own convenience, so no worries. Okay, let's move on to this figure. Okay, great. So once we have this F pattern again, right? Okay, so we have this and we have this, right? So that means it's from the same position, right? If you look at your F pattern, can you guys see this? So that means we can actually say that 12x plus 19 is equal to 14x minus 1, right? So once you have that, all you have to do is solve for x. So you have 14x minus 12x, so that would give you 2x, and this is basically 20 divided by 2, therefore x is equal to 10, right? So in order for you to solve for this and this, all you have to do is plug in 10. So 14 times 10 is 140 minus 1, that's 139, right? And for this, right, let's say this is this is 120, right? Because it's 12 times 10. That's 120, then you have plus 19, that's equal to 139. And because they're corresponding angles, right? So this is what you call corresponding angles because they're on the same side of the transversal, right? So these two are congruent. Okay, great. So let's move on to the next figure. Okay, so now we have parallelograms, right? So if you recall, when we're talking about parallelograms, basically you have this side, so the opposite sides are congruent, right? And also, if you look at the angles, right? So you know that this is 137, so the opposite angles will be supplementary, right? So that means if you have 137 over here, in order for you to solve for y degrees, you would take 180 minus 137, and that would give you y degrees, right? So 180 minus 137 is equal to 43 degrees. Therefore, this must be 43 degrees, right? And if you have 137 degrees over here, the opposite angles, they're congruent, right? So if this is 137, therefore you can actually say that x degrees is 137 degrees because they're congruent. Okay, so that's the thing for parallelograms. Okay, so interestingly, we have a diagonal over here, and this is a rhombus, right? So for rhombus, right, all of your sides are equal, right? But that doesn't really tell us how to solve for y, z, and x. So that means in order for us to know what the angle is, right, just remember that your diagonals, they're actually the same, right? So when you have a diagonal over here, again, this is the z pattern, right? Can you guys see this? Here, and you have this. Okay, that's supposed to be an inverted, or yeah, it's supposed to be an inverted z. So there. Oh my goodness. Okay. Here. Okay, can you guys see this? Basically, that's what I wanted to point out. Okay, basically that's the z pattern, right? So it's sort of inverted, right? So if you know that this is 55 degrees, therefore this has to be 50, well, not the whole thing, right? Only just y. So this has to be 55 degrees as well, right? Because based on the z pattern, right? Because they're alternate, that means if you have this and this, right? So if this is 55 degrees, right? That means this has to be 55 degrees as well. Does that make sense? And then in order for you to solve for x, right? Remember, because it's a rhombus, right? The opposite sides, right, they're supplementary, right? So if this is 55, right, in order for you to find the whole thing, which is this, right, not just 55, all you have to do is take 180 minus 95, and that's equal to 85 degrees, right? So the whole thing is 85 degrees. Just in case anyone is wondering why my pen is like this, right? Apparently it's chipped, so that's why it takes me a while to actually write things down, and sometimes like the majority of what I'm trying to write is missing, so that's the reason why. Okay, so this is 55, right? So you know how this whole thing is 85, so therefore in order for you to just find this part, right, that would be 85 minus 55. So that's equal to 30 degrees, right? So if this is 30, therefore you can say, again, this is going to be a different z pattern, right? Can you guys see this? So from here, here, and here, this is 30 degrees as well, right? Does that make sense? You have another z pattern here, right? Here, here, and here. Okay, so now that we have that, right? So we know that this is 95, right? And if this is 85, right? This is 85, therefore this has to be 95, right? Let's use a different pen. This has to be 95 degrees, right? Because the opposite of 95 degrees, they need to be congruent, right? For the angles, because it's a rhombus, right? And the same thing really applies when it's a parallelogram. So for this figure, right? So since we have, well, yeah, we have a parallelogram, right? And we know that the diagonals of a parallelogram, right, they intersect, right? However, we also know that they're equal to one another, right? So let's say they're saying that this is 10, right? That means this has to be 10 as well, right? Because this and this, they're going to be equal. And if you have this and this, they need to be equal as well, right? Because this whole thing is equal. Does that make sense? So although it's a parallelogram, right, this and this, they're not equal. However, when you have this point over here, this and this one, they're equal, and this are equal. So that's what a parallelogram looks like. So that's for diagonals. Okay, so I think this is pretty straightforward because it's a parallelogram, so the opposite sides must be congruent. Therefore, for x, this is 22, and for y, this is 16. Because opposite sides are congruent. Right, so this one is the same thing, right? This is 17. And because you know that this is 78 degrees, right? In order for you to solve for y, then that means this would be 180 minus 78. So that would give you 102. So this is 102 degrees. Okay, great. So remember what I said about parallelograms again. Opposite sides are congruent, right? That's why this is 5, because this is 5. And the diagonal, they're also congruent, right? So if this is 4, therefore this has to be 4. Okay, so now that we have this figure, right? So anytime you have a diagonal, right? I think a lot of students, they just feel overwhelmed. So if you have 78 degrees here, right? The first thing that you need to really find is this whole thing, right? So because once you know what this whole thing is, that kind of answers the question for this and for this, right? So this, we know that this is 53 degrees, right? But how do we find this whole thing? So all we do is we take 180 minus 53 because we know that the opposite angles, right, in a parallelogram, they add up to 180 degrees, meaning they're supplementary. So that's why I'm taking 180, subtracting that from 53, right? So if you have 180 minus 53, this is equal to 127, right? So once you know that this is 127, therefore this must be 127 as well, right? And because you know that this whole thing is 127, in order for you to find just this part, it would be 127 minus 78, and that would be 49, right? Okay, so first of all, how do you know which one is 78 here and which one is 49? Well, you're going to apply the z pattern, right? So the z pattern, if you know that this is 49, therefore this has to be 49 and this has to be 78, right? Because if you look at this z over here, right, this is alternate to this. Does that make sense? That's why this is 49. And this C over here, angle C, is actually opposite to 53 degrees. Therefore, you know that this is 53 degrees. Okay, so I don't think this is a hard question because this is a parallelogram and we know that the opposite side, they're congruent. Yeah, opposite sides of a parallelogram are congruent. Therefore, if this is 24, this must be 24. Opposite of 15 is also 15 because it's a parallelogram. And guess what? Because if it's a rhombus, right? If you're looking at a rhombus as opposed to a parallelogram, since we know that a rhombus is very similar to a square, right? Although the sides are similar, right? There's still two different polygons, but for a rhombus, right, all sides are equal, and it's similar to a square in that way, right? The only difference is in a square, right, you have right angles in the four corners as opposed to a rhombus. Okay, great. So now we have a rhombus, right? So this is 12, this is 8. So I guess for this question, all we have to look for is the diagonals, right? So the diagonals in a rhombus, they're perpendicular, right? Also, that's another thing to keep in mind, right? When they're perpendicular, that means it creates a bisector, right? It's a perpendicular bisector. So this is a right angle. Yeah, I know this is not really related to the question, but I just thought of just mentioning that right now. Okay, so this is 8 and this is 8. Therefore, this is 12 and this has to be 12 as well. Okay, again, this is a parallelogram, right? So you have 2x minus 3 and that's equal to x plus 10, right? Solving for x, you would have this minus x, right? Because I'm moving this to the opposite side, I get x, which is equal to 13, right? 10 plus 3, that's 13. So this would have to be 23, right? And if this is 23, this has to be 23 as well, because 2 times 13, that should be 26, right? Minus 3, that's 23. Okay, so we have a couple of parallelograms here, right? So remember, because this and this, right, they're opposite to one another, therefore you would have this and this being equal to one another because they're congruent. So this is x plus 46 and this is equal to 3x plus 10. Okay, so in order to solve for x, you would have this minus this, so that would give you 2x, and this is equal to 46 minus 10, right? That would be 36, right? Divided by 2, that would be 18. So x is equal to 18. Okay, so now that we know that this is 18, so 18 times 3 plus 10 is equal to 64, right? If this is 64, then this must be 64 as well. So 18 plus 46 is equal to 64, right? Because this is congruent to this angle, right? And let's say if you wanted to just find what the angle is for this, right, out of your, I guess, your curiosity, so all you have to do is take 180 minus 64. Then you would have to find this angle. So 180 minus 64 is this angle. And this angle, right, because they're opposite. Okay, so you're looking at angles that are on the same side now, right? So if they're on the same side, that means this 9x plus 15, it's congruent to this side, right? And this side, or this angle, is congruent to this angle, right? So if this angle and this angle are congruent, that means these two angles over here, they need to be supplementary, right? So if they're supplementary, therefore you can just say that this and this adds up to 180 because this is the exact same angle. This is 6x plus 15, and this is also 6x plus 15, right? Over here. Okay, so you can actually say that 6x plus 15 plus 9x plus 15 is equal to 180 because of the fact that this is 6x plus 15 and you know that this is 6x plus 15. Okay, so 9 plus 6 is 15x, and you have 30, which is equal to 180, right? And 180 minus 30 is equal to 150, right? So you have 15x, which is equal to 150, dividing both sides with 15, you get 10, right? X is equal to 10. Okay, great. So once you have that, you can actually plug in 10, right? So 9 times 10 is 90, right? And then if you have 90 plus 15, that's equal to 105, right? Okay. And for this angle, right, it's either you take 180 minus 105 or you just plug in 10 times 6, right, which is 60 plus 15. So 60 plus 15 is equal to 75, right? So you know that this is 75 degrees, right? And just to double check, if you take 180 minus 105, you should get 75 degrees. Okay, a couple more for parallelograms, and we're going to move on to harder ones. Okay, great. So remember for diagonals, because they're exactly the same one, so if you have x minus 5 and you know that this is 2x minus 17, they need to be equal to one another, right? Because they're on the same side of the diagonal. So all you have to do is have x minus 5, this is equal to 2x minus 17, right? Then you're moving 17 to the opposite side of the equation, so you get 17 minus 5. So that's equal to 12. Yeah, this is 12, and this is 2x minus x. This is x. Therefore, you know that 12 is x. So this 12 minus 5 must be 7. And yeah, this must be 7 as well, right? 12 times 2, 24, minus 17, it's also 7. Okay, so in here, because you know that this is a parallelogram, right? Therefore, this 3x plus 11 is going to be equal to its opposite side, right? Therefore, we can just say 3x plus 11 is equal to 5x minus 9, right? So once we have that, we take 5x and we have 3x over here. Therefore, this is going to be 2x, and this is 11 plus 9. So that's going to be 20, right? Divided by 2, so we know that x is equal to 10, right? So once we know that this is 10, then this is 3 times 10, which is 30 plus 11, right? 30 plus 11, that's equal to 41, right? So if you know that this is 41, this also needs to be 41, right? Because it's 50 minus 9, that's going to be 41. Okay, so now we have this again, right? Because they're on the same side of the diagonal, therefore they need to be exactly the same. They need to be congruent, in other words. So we have 2x minus 3, and that's equal to x plus 27. Therefore, solving for x, 2x minus x is equal to x, and you have 27 plus 3, right? That's equal to 30. Okay, then this is 30 times 2, 60 minus 3, 57, right? Yeah, and this has to be 57 as well, right? Because 30 plus 27 is 57. Okay, we have x plus 50 degrees and x plus 36 degrees, right? So because we know that these two are supplementary, right? All we have to do is equate this to 180 degrees. So x plus 50 plus x plus 36 is equal to 180 degrees. So this is 2x, right? And you have 50 and 36. So 50 plus 36 is equal to 86. Then you have 180 minus 86. This is equal to 94, right? Dividing both sides with 2, right? 94 divided by 2 is equal to x is equal to 47. Yeah, so we know that this is 47. Therefore, in order to solve for this angle, you would have to just plug in 47 plus 50. That's equal to 97 degrees. And this over here, because it's 180 minus 97, that's going to be 83 degrees. So you would take 47 plus 36, right? 47 plus 36 is equal to 83 degrees. Okay, so here you have 3x plus 3, and here you have 4x minus 4, right? So because they're congruent, right? They're opposite angles, right? That means this and this will be congruent, and this angle will also be congruent. So therefore, you have 3x plus 3, that's equal to 4x minus 4, right? So this is 3x plus 3 equal to 4x minus 4. Okay, so once we have that, 4x minus 3x is equal to x, then you have 3 plus 4, which is 7, right? So we know that x is equal to 7, so in order to find this, you would have 4 times 7, 28. 28 minus 4, that's 24, right, degrees. Then this would be 3 times 7, which is 21. 21 plus 3, that's 24, right? Again, they're congruent. So yeah, if it's a parallelogram or it's a rhombus, the opposite angles will be congruent. And if you have angles on the same side, they're supplementary. Now we have this, right? So we're now looking at sides, right? Again, it's not too it's not too bad because this is just going to be equal to this, right? Because we know that this is a rhombus. So we have negative 2 plus 4x, and this is equal to 3x plus 3, right? So 4 minus 3, that's equal to x. Then you have 3 plus 2, which is 5, right? Therefore, solving for this, right, you would have 3 times 5, that's 15, right? 15, 16, 17, that's 18, right? There we go. And for this, you would have 4 times 5, right? PEMDAS, remember? Multiply first before you add. So this is 4 times 5, 20. 20 minus 2, that's 18. So because it's a rhombus, right? Therefore, all sides are equal. So it's 18. So if this is 18, this is also 18, 18, and 18. Okay, this is a parallelogram, right? Because the opposite sides, right? They're congruent, but not all sides are equal. So again, we know that this is 50x and this is 130x. Therefore, adding both would give us 180, right? Because they're angles that are on the same side. So this is 130x plus 50x, that's equal to 180, right? So 130 plus 50, that's equal to 180x. This is equal to 180, dividing both sides with 180, you get x is equal to 1, right? So once you know that x is equal to 1, therefore this has to be 50 degrees, and this has to be 130 degrees. And if you try to add these two, you should get 180, right? Because they're on the same side and they're supplementary. Okay, so you have 2x plus 30 degrees, and you have 2x minus 10, right? So okay, think about this. If you have 2x minus 10 over here, that means this has to be 2x minus 10, right? So that means this and this must be supplementary, right? So if you have 2x plus 30, right, plus 2x minus 10, this needs to add up to 180 degrees, right? So even though right off the bat, just by looking at the figure, it's kind of hard to tell, are you supposed to add them and sum up to 180, or they're supposed to be equal to one another, which is congruent, right? So I tell my students that, it's okay to just look at the figure and see which one is easier to visualize. So if you have 2x minus 10 over here, then probably if you would infer that, okay, this is 2x minus 10, we know that opposite angles in a parallelogram are congruent. So it's just easier for you to see that because they're on the same side, therefore they're going to be supplementary, right? You don't need to just look at the figure and be able to tell things. That's what I was trying to get at. So sometimes it's just the way your brain works and the way you look at the picture. Does that make sense? If you know that it's easier for you to see that, okay, this is here, right? That means they need to be supplementary. So it's 2x plus 30 plus 2x minus 10 is equal to 180, right? 2x and 2x, that's 4x. And you have 30 minus 10, that's 20, right? So 180 minus 20, right? That would be 60. 160 rather. So you have 160 over there. Great. 180 minus, yeah, it's 160. Therefore, dividing both sides with 4, right? You have x is equal to 40. Yeah, okay. So because we want to plug in x, right? That means this needs to be 80, right? 80 plus 30, that's 110. Yeah, 40 times 2, that's 80 plus 30, 110. That means this has to be 180 minus 110. Or you can just plug in, 40. So 40 times 2 is 80, and you have 70, right? Because 40 times 2 is 80 minus 10 is 70 degrees. Okay, so when they're trying to say that this is 2x plus 20 degrees, that means it's this, and you have x plus 30, which is this, right? And because it's a diagonal in a parallelogram, they need to be equal to one another. Therefore, this is 2x plus 20, and this is equal to x plus 30, right? So 2x minus x, I'm just moving this x to the opposite side of the equation, and I'm getting 30 minus 20, that's equal to 10. So we know that x is equal to 10, so when you plug in 10 over here, this is 40, right? Oh, actually, this is degrees. Okay. So if they were diagonals, then you can actually say that. But because they're degrees, right? So yeah, you need to pay attention to the units, right? Okay, great. So this is x plus 30, this is 2x plus 20. So they're saying that this and this, right? What can you say about these two angles, right? So if you try to visualize this, so yeah, pay attention to the units. You have this over here, this and this, right? Can you guys see the Z pattern? So basically this and this over here, because they're alternate, you can actually say that they're equal to one another, right? They're congruent. So you have 2x plus 20, that's equal to x plus 30, right? Degrees. So 2x minus x, that's x, and you have 30 minus 20, that's equal to 10. Okay, great. So they're angles, right? So you know that this is x is equal to 10, so this is 40 degrees, right? And if you know that this is 40 degrees, therefore 10 times 2 is 20 plus 20, that's 40 degrees. Okay, so I guess that's it for the previous class. So let's move on to the new one. Okay, so now you can actually see that there's more variables, right? Again, you know, math gets harder and harder, right? So that's why we have this. Okay, so interestingly, this is a rectangle, right? So in a rectangle, that means all you have to know, you have opposite sides that are equal to one another, right, in terms of measurements. And also, you can actually remember that, actually, even in, I guess, in middle school, right, if you're looking at a rectangle, that means here, right, you're forming a right angle. So you have 4 right angles, and on top of that, you have opposite sides that are equal, right? That's what a rectangle is. So also, don't forget, you still have diagonals, right? So I think this is, I guess, the newest information that you need to know, as opposed to just having the right angles and also opposite sides being congruent. So diagonals, they're actually congruent as well. So if you know that this is 8, therefore this must be 8 as well, right? So, okay, let's look at this. So this is an angle, right? So this is 60 degrees, right? So you know that this is a rectangle, therefore this is going to be a right angle, right? So in order to find d degrees, you would have 90 minus 63, right? So 90 minus 63, that's equal to 27 degrees, right? Okay, so the Z pattern would still apply here, so it's not like you need to forget about that and just focus on the rectangle. No. Everything is going to be applied here, right? So you have to remember your F pattern, your Z pattern, right? Your X pattern, and so on and so forth. So if you draw your Z pattern, right? Can you guys see this? So it's an inverted Z. If this is 27, this must be 27. A degrees must be 27 because the Z pattern, right, is basically from here to here, and then you go down and then over here. So whatever this is, if this is 27 degrees, this has to be 27 degrees. And guess what? You can actually draw another Z pattern this way, right? So if this is 63, this must be 63 as well. And yeah, we're done. Okay, so in the rhombus, right, remember in a rhombus, basically when you have diagonals, right, they form a perpendicular bisector, right, when they intersect. So that means this A degrees needs to be 90 degrees, right? So yeah, this is 90 degrees, right? So A degrees is 90 degrees, right? And how do you find B? Well, if this is 60 degrees, right, then in order for you to find B, you would have to take 180 minus 60, right? So I'm just adding 30 and 30. So this is 60 and you have 120, right? Therefore, B degrees would be 120. Okay, so once you know that this is 120, this is 5, right? Over here, because opposite sides are equal, right? And on top of that, all sides are equal in a rhombus. So if this is 5, this is 5, this is 5, and this is 5. And yeah, that's it. So we've solved all of the variables. Okay, just so like if the question asks, right? So say for example, what is this angle, right? So this angle is also 90 degrees, right? This is also 90 degrees and also this, right? Because it's a perpendicular bisector, right? So all of your angles would be 90 degrees. Okay, so in this figure, we have a square, right? So what can we say about a square? So a square is basically the properties of a rectangle and a rhombus combined, right? So if we're looking at a rhombus, right, all sides are equal, so does the square. For rectangles, if diagonals are congruent, so does the square. And if you're looking at the four right angles, right, because we know that in a rectangle you have four right angles and so does the square, right? So basically just imagine, picture this in your head. It's a hybrid of a rectangle and a rhombus. That's what a square is, right? So all the properties belonging to a rectangle and a rhombus, you combine them together, you get a square. So that's what this is, right? So if you have 4.2 here, right, I know that they're not really asking what this is, but basically this is also 4.2, and so is this. This is also 4.2. So this is a 4.2 as well. And if you have 3 here, that means this is 3, right? And what else? This is 45 degrees, and this is a right angle, right? So if you have 45 degrees here, you can apply the Z pattern, right? This must be 45 degrees as well. And how do you find this and this? That means 90 minus 45 would give you 45 degrees. Therefore, when you apply the Z pattern again, you know that this has to be 45 degrees. Okay, wonderful. Okay, that's it. But let's say if they're asking specifically if you have AD, right? Because this is how they're going to ask you on the test, right? As opposed to just looking at the figure and trying to complete the variables. So if you're looking for line segment AD, right, it's basically 4.2. And if you have the measurement of angle BCA, right, so BCA is here, here, and here, right? That's what BCA is, BCA. So that's 45 degrees. If you have line segment AC, that's equal to 6, right? This plus this, that's 6. And if you have line segment BD, right? Line segment BD, if you have this being 6, right? The diagonals, right, in a square is actually equal. Therefore, if this is 6 on the left, right, the right has to be 6 as well. And if you're looking at the measurement of BCD, of angle BCD, right? BCD, it's actually 90 degrees, right? And lastly, the measurement of angle ACD. Okay, so where is ACD? So ACD is here, here, and here. It's still 45 degrees. So that's how they're going to probably ask you during the test. So pay attention to that. Because it's not just filling out whatever is found in the figure, right? Sometimes you can also get, fill in the blanks based on your line segment and the measurements of your angles. Okay, so we have this rectangle. This is 30 degrees, right? This is 8, therefore this must be 8 as well. Okay, so remember, because in a rectangle, the diagonals are also congruent. So if this is 8, this has to be 8 as well. Okay, great. So now that we know that this is 30 degrees, right? And it's a rectangle, therefore this must add up to 90 degrees, right? So 90 minus 30, this has to be 60, right? And again, the Z pattern applies, right? So if you're looking at this, right? This is a Z pattern, right? So if this is 30, therefore this has to be 30 as well, right? And guess what? If this is 30, therefore this, if this is 60, right? Another Z pattern over here. This is 60, therefore this has to be 60 as well. Okay, so once you know that, let's look at this, right? If this is 13.8, therefore this has to be 13.8 as well. Okay, so maybe if they're asking us in terms of line segment EG, so what are the dimensions? So line segment ED is EG rather, is simply 16, right? It's 8 plus 8, that's 16. Measurement of angle FHG, right? So FHG is over here. So FHG. Okay, so since we didn't really look at that yet, right? So if you have FHG, right? Okay, so think about this. If you know what the angles are for this and this, right? So maybe we can actually find some sort of a relationship between this angle and this, right? Well, obviously we know that looking at this angle, this is 90 degrees and this is also 90 degrees, right? But what about this, and this? Because we're looking for FHG, right? So let's see. Okay, so if we tried using... Okay, so this angle and this angle needs to be the same, right? Because if you draw the Z pattern over here, this needs to be... Yeah, this needs to be the same angle, right? Because they're alternate, right? And okay, what else? This angle over here and this angle, right? Can you guys see that? So this and this needs to be the same, right? But let me just delete that right now. Okay. So that means if you know that this is 30, yeah, if this is 30, this has to be 30 as well. And then let's say we know that this is 60, right? And yeah. Okay, so once we have that, right, this is 60 and this is also 30, right? So FHG is actually 30 degrees. And then line segment FH. So line segment FH is 16, right? And line segment EF. So EF is 13.8 over here. Okay, measurement of angle HEF. And lastly, the measurement of angle HFE. Okay, HEF is 90 degrees, right? HFE is going to be 30 degrees. Okay, great. So that's how we're going to solve for this question. Okay, great. So because we only have 2 minutes left, and this is going to take a while for us to actually continue, so I'm going to wrap this class up. Okay, great. And yeah, if you do have any friends, who might be interested or who you think might benefit from this, please ask them to join. I always have my classes for geometry and for algebra 2, right? Because you're probably going to take algebra 2 in the future every Saturdays, right? So if you're interested, just go to oneclass.com/livestream. Let me just write that down. So yeah, this is where you can actually see my daily schedule, right? I teach calculus and vectors and other math courses, right? And also, yeah, I mentioned algebra 2, right? If you have any friends, please ask them to join, right? And also, there are other talented educators who are also hosting live classes and they're daily. And guess what? They're free. So make sure to check that out. And yeah, I'll see you on my next class. Thank you so much, guys, for tuning in and happy Saturday. Bye, guys.